Side where it's like all the pictures and all the stuff right here, right? Leading out to like the hallway. Yo, you know what I'm talking about? Yeah. Then you got the other side that we closed off.
And then like these like the gym stuff. Just like it over there. It's just time to be connected to it.
What do we think about that, though? What do you think about that?
Figured it out.
Awesome. What'd you get? Mm-hmm.
Wait, is this the one? 4760.
Nope. What made you think that? Like, let me go.
Yeah, what made you think that?
Shut up,
you
bro.
think you know everything.
To be fair, the calculation you did is not what you got. What you just said out loud. Look at what you had.
What?
'Cause
I
that
said
one's-
4763.
But the answer that you calculated is different than that.
1760.
There you go. That's right.
So I was right.
We still got to be able to translate it back into like communicating it. Being right is all well and good, but we got to make sure we write the right answer too. So what do we notice on this? There's a piece missing from each one of these. There is one raspberry missing from all of these things. Because I got one missing here, I got one missing here, I got one missing here. So whatever's happening to this pattern, we know for sure we're going to take one raspberry away at the end. So if we had that raspberry back, make it chunky raspberry. There we go, raspberry. Ooh, I'm so good at drawing. Beautiful raspberry. Does that help us see what's going on with this pattern? What do we have here?
2 by 2.
Yeah, we've got a 2 by 2 square. Here I have a 3 by 3 square. Here I have a 4 by 4 square. So what do we notice with that? Mm-hmm. Because this side, whoa, is very skinny on a pen. Because this side, we could write it as 1 plus 1. And this side, we could write it as 1 plus 1. On the next one, I could write this as 2 plus 1 because we want to use this number here. One of these ones came from this guy. And this is also 2 plus 1. If we notice on the big one, I could write that as 3 plus 1, which we like because I want to be able to use this 3. So how can I write this for like an equation kind of thing? What would we have? If I didn't know what figure number it was and I wanted to find the width of it, the side of it, I could take that figure number and we add 1. So we had 1 plus 1, 2 plus 1, and 3 plus 1. But that just made one of my sides. So if we wanted to get it as a square, we could square it. So this would be a general form, like a form of an equation we could write for this. Not the only way we can do it. There are lots of ways through it. But we should have wound up with what value for pattern number 41? What do we get? What we get? 1763. If we put in 41 here, 41 plus 1, so we'd have 42 squared, and then we have to take away 1 for our little missing raspberry, this guy that was taken away in here. So our 42 squared gives us the big square of raspberries, and we have to take one away for the little hole. So when in doubt, if we have something that's vaguely squarish, see if we fill in that box, if it helps us figure out how to find the outside sides. Okay? What we're going to do today is we're going to look at some equations in our workbook that are very much like the e-learning assignment from yesterday. So we are gonna look at page 83 to start, and then we're gonna do page 80. So we're gonna bounce around just a little bit. Page 83 is the wrong number. Page 81.
That right there, like, I thought you were doing it, you gonna come all the way down the hallway to explain how you not doing it. And she was doing it, but I'm not even your student, and she be like, other things like that. And she come up to me, and all people in the hallway, she come up to me.
Teachers are inherently nosy. Just saying. Yeah, all of us. Every one of us. Every one of us. All right. So we're going to take a look at this. There was a problem very similar to this on the e-learning assignment. So looking at 3 different equations here. And this is on the kind of bottom half. So we've got a company's profit in thousands of dollars. Depends on a lot of information here. So they went to their accounting department and said, hey, write me an equation for our profit. And 3 different accountants came back with 3 different equations. Super helpful. How could we convince somebody that these are the same thing? We could test some values. That is an absolutely valid way of proving it. We'd have to test several to make sure it works for all the things, but we could test some stuff. Ooh, I don't know. We could test values. What's up? I know.
Let's all take a class now.
No. Sorry, but no. No class nap. All right. We could test some values. We could also come through and kind of do some multiplying out. We know how to multiply things like this. We've done that since Algebra 1. We could multiply things out. We could change the forms. I was going to say, if we set them equal to each other, we would need for it to be like infinitely many solutions. So we'd get like a 0 equals 0 or an x equals x situation, which you could totally do. As going to be hard mode though. Easy ways to like multiply it out and say, hey, look, if I multiply out factor form, I got standard form. If I multiply out vertex form, I get standard form. Pretty much that's going to be the way we would do that if we were trying to prove it. So the reason we have different forms is they tell us different things. So I go back to the accounting department at our business here, and we say, dude, 3 equations, be so for real. I want to know where a company breaks even. I need to know where we stop losing money and when we start making money. Where is that going to happen? At our zeros. So our break even, that's when our profit is 0. So which of our forms would be helpful to know when our profit's 0? The second one. Remember what this one's called? It does have something to do with roots. It's actually called our factored form, though. But it's made from our roots. Absolutely right. Absolutely right. So this is our factored form. Factored form would help us figure that out. So what would those prices be? looking at that equation, where do we start turning a profit? We're gonna look at this guy.
Oh,
Careful, careful, careful. Our factored form, like the original form of it, when we wrote it down originally, that was our AX minus R, X minus S, just because we don't like to use R twice. So be careful. What are our values of our roots? +3 and +9. Okay, so be super duper careful. So if I set the price of my products at $3, or if I set it at $9, I will make 0 money. I won't lose money, but I will not gain money. I won't lose money though, so. So then the next time I go to my accounting department and say, okay, new question. What happens if I start giving stuff away for free? If my price is 0, what is our profit going to be if the price is 0? How could we tell that from one of these equations? It's not going to be our vertex form.
standard?
It's gonna be our standard form. That's going to be what happens at our intercept. Exactly right. I'm gonna give us a picture real quick. I'm gonna change the view. Because what this whole situation is looking like is we've got ourselves a parabola that looks kind of like this. That's a terrible parabola, but it's a vibe. So it looks something like this. It's very scribbly. I should just use the chonky pen. That'll just make things way easier. Whoa, that is not better. Chonky pen. And what we had before, our profit being 0, were these guys and these guys. So what we want to know now is I want to know what happens when my price is 0, because my X's are my price. My X's are going to be 0 where? If my price is 0, how much money will our company make or lose? We're going to lose our 54. It's this guy. In our standard form, that shows us what happens when X is 0. So we know our y-intercept is going to be at 0, -54. So we lose $54,000 if I start giving stuff away for free. That's this guy down here, our -54. So now that we're looking at our profit equation over here, because that's what this is showing us, if I want to know where I'm going to make the maximum amount of profit, vertex. Whenever we see maximum or minimum, that means we're looking for our vertex over here. Where is our vertex in our equation? This guy was our standard form. Yeah. Our vertex form is this guy over here. And our vertex is going to happen at the point 618. So what price should we set our item that we're selling at to make the most money? Which one is our price?
Oh, $6.
6. So if I set my item at $6, I will make the most money available from the data that we got. So looking at all three forms, we can tell different things from our equation. What's up?
What does the 18 mean?
So the 6 is the price for the unit because X is the price at P dollars. The Y is our profit, is the company's profit. They would make $18,000. That's what this guy is. So this one is my, I'm just gonna label stuff. Profit. Just since everything's a money, let's make it not be a dollar sign. This will be price. I generally try and stop us from having the same variable on things. I don't like to talk profit and price. I'll usually do it as cost and price or income or something like that. Okay, so the three different forms of equations tell us different pieces and different things. So what we're gonna do is we're gonna practice identifying some of those pieces, and we're gonna start working our way towards being able to solve some of these. By the end of the next week, we're gonna be solving stuff and like doing factoring and all that stuff. So let's take a look at page 80. So it's gonna go back a page. And we're given another situation. And I want us to see if you can figure this out. See if we can figure out how high the springboard is. When does the diver hit the water, if we can. And how we could figure out C or D. So look at these and see what we can do. See what we can do. I want you to give these a shot. See what we can come up with. Oh, I'm gonna change the view. Right there. Like I can't open the window when he's standing right there. I'm not supposed to open them anyway. I will always be the one that breaks the rule to open the window. Every time. I'm just not gonna do it blatantly in front of the police officers. Come up with on this. What do we think? How high is this diving board from the water? 3 meters. How do we know that? It's our C. It's our starting amount. It's our intercept. So that tells me that when we have this pool, ooh, fancy schmancy, and we have a diving board, and I jump it, there's me, woohoo, and we jump this height, our starting point is 3 meters. That's what this is telling me. So 3 meters is my y-intercept. So when does the diver hit the water? How can we figure that out? I'm not saying we're going to find it. I'm just saying how could we find it? Set the height to 0. If height equals 0, so we get 0 equals our minus 5t squared plus 10t plus 3, then we could figure out where that is. That's what this is asking us for, is when does the height hit the water? When is the height 0? Because that's the water. To be able to do this without a graphing calculator, we would need to use one of our other tools. We would either need to try and factor something. We could try and put this into a vertex form. We could use quadratic formula from way back in the day. But at this point, no. We've not done anything with it. This one does not factor nicely. We would need to use our quadratic formula, which is generally unpleasant. But we could. What about for number C? Letter C. Hang on, I'm going to grab my picture again, just so we can have it.
What's the quadratic formula again?
Hang on a second. I will write it down for you. Uh-huh. So, there we go. So our quadratic formula, when we need it, I will get it to us when we get a little bit later on. But just since we've mentioned it, that's our x equals negative b plus or minus square root b squared minus 4ac divided by 2a. If you would like to memorize that, you are welcome to. There are so many songs on YouTube. If you ever get bored and run out of things to watch on YouTube, the quadratic formula songs are oh so bad. There's some of them that are just epic in that really cringy, I can't believe you put this on the internet for other people to see kind of way. There's covers of Dre songs. There's covers of, like, I know Superman. Yeah. 2A. Oh, they do the whole dance. There's choreography. There's so many. So you don't have to have this memorized. We're going to talk through it at the end on why this thing exists and why we have this, but that's really close to the end of this chapter. So for the most part, we're not using that. We're not going to use this right now for sure. I'm going to get rid of it. So C we can absolutely do right now. And this is going to be our very first thing that we ever do for solving these, is looking at C. So we want to know at what time, so when, after I jump, are they the same height as the springboard? So we already said that our springboard was 3 meters high. So what are we trying to figure out? Let me get rid of that piece. I don't need that. That was copied over from the last page. So for part C, what is it we're trying to figure out? I want to know when they get to the same height as the board. So looking at my jump over here, I want to find that guy. I think you can see that. How can I find that guy? Setting our height to 3. I know how high the board is. My 3 equals my minus 5 t squared plus 10t plus 3. We can set our height to 3. What could I do then if I wanted to try and actually figure out what those values were? What would we need to do first? What would we need to do first?
Got it.
Thank you. Your goodies. What could I do if I wanted to solve this thing? What would we do first? When in doubt, set it equal to 0. So let's go ahead and subtract 3 from both sides. That's going to give us 0 on the left side. And that 3 and that 3 are going to cancel out. So we're left with our minus 5t squared plus 10t. What can I do there? I like the thought, but not quite. I want to keep my t's together over here. What do those two pieces have in common? T. We can factor this. I could factor out a t that's common between them. So I could rewrite this as 0 equals t. Is there a number that I can take out of both of those pieces too? 5. I could take a 5t out. That's going to leave me with minus t plus 2, right? If I take a 5 out. If we were trying to solve this, think back to factored form back in the day when we did it with parabolas. That's when we take each of our chunks and we set them equal to our 0. So I want to know when 5t equals 0. And we want to know when our minus t plus 2 equals 0. So on our left one, 5t equals 0. How can I get t by itself? Divide by 5. So our first answer is that t equals 0. That's legitimately when I start. So the first time I'm at height of 3 is when I jump off the board. So let's see what happens on the other one over here. So we're going to minus 2 from both sides. That's going to give me a darker green, it's easier to see. Minus t equals minus 2. So what does t equal? 2. So 2 seconds into this dive is when we're at this same height. So sometimes we can find these values easier than we can find the pure zeros. Because if we're looking for exactly the height where we started, we're going to be able to factor it a lot easier. If we were looking for the peak of our dive, what point would we be looking for? Our maximum, also known as our vertex. Can we get our vertex from right here in a graph? Do we know where it's going to be? There's some ways we can kind of logic our way through it. Like, we know it's going to be somewhere about here. We know that's going to be about halfway between where I started and my time is 2. But at this point, we don't have a pure way to get to our vertex. I haven't showed you yet what we're going to be using. If you remember from Algebra 2, that's great. You can do our completing the square, or we can put it into vertex form another way. We're going to have all kinds of pieces for it. So what we're going to start working through is we're going to start working towards being able to take equations that are in factored form or in standard form and put them in vertex form, being able to solve them. That's what we're going to be working towards as we finish out the next page that has like that little table at the bottom. That's the, oh, I love that. These two are hooking together now. Fun times. Page 82, that's what we're going to start working with, I believe, tomorrow to fill in that table. Working through, starting to be able to change between the forms and find other pieces. Okay, so we now have about 8 minutes left. Please make sure you guys do the homeworks that are up on Canvas. Again, the end of the chapter or end of the quarter is Friday. So report card grades are going to be pulled early next week. You guys still got time to change where you can change your grade and stuff. If you're ever wondering what even is the point, how much is this even going to affect my grade, go on your Chromebook or on your computer to the Canvas page. And if you go into grades, you can put in values and see what happens if I do turn in all these assignments. What happens if I make up this thing? What happens if I redo this? Or the what if grade. That's part of the reason I use the Canvas gradebook. Is you can do the what happens if I turn in all my stuff without me having to do it. Okay? So, quarter ends on Friday, which means anything you want in for report cards, get it in by Monday at the latest. Yes, dear. That would be, I think it was the first test. I think I was missing from you. But let me look. Or it may have been the project. Let me look. All right, I've got all of the projects, unless you turn it in today, should be